Welcome back, Chapter 5, Lesson 1, Exponents for today, folks. Starting a new lesson and a new unit. Now, we have learned in the past how to multiply. We've even learned in the past, what if you had a 2 times a 2 times a 2? For today, we're going to talk about using exponents to simplify algebraic expressions. Of course, we got to crank it up a notch, right? So that's why you will see both perhaps numbers and variables, moving eventually into using these skills to simplify more complicated numeric or algebraic expressions involving exponents. So pause, whatever the date for the day, whatever the assignment number, pause, copy this down, come on back when you're ready for some notes. All right, ladies and gents, what are exponents? Perhaps you've heard the word, I'm sure you're similar to it. I'm sure you're familiar with it, excuse me. An exponent is a number that tells how many times a base number is used as a factor, a repeated factor, in fact. So for instance, take 5 to the third power. Notice I'm going to focus on that word power. A lot of people say exponent a lot. An exponent is only a part of a power. The base is the number that is multiplied repeatedly. So you'll see 5 multiplied by itself. The exponent is a part of that power that tells you how many times that factor is repeated. Since the exponent here is 3, you'll see 5 multiplied by itself 3 multiple times. So 5 times 5 being 25, of course, and 25 times 5 is 125. So a little vocabulary for you. A base raised to an exponent is all a part of a power. We're going to write this as a product, and oh, there's Mr. Collins' pet peeve. This word is not solve. You can use the word compute, which is a fancy way for saying do the math, add, subtract, multiply, and divide. Some of us will even use the word evaluate, find the final value, but this is not an equation, therefore it is not going to be solved. Let's take a look at 4 to the third power and do this together. I see 4 is the repeated base. I see a power of 3, which means I'm going to multiply 4 by itself. There should be 3 factors. Now, of course, 4 times 4 is 16. 16 times another 4 is 64. Example B, 7 to the second power. I see an exponent of 2, so I should see 2 repeated factors. And in this case, the base is 7. So 7 multiplied by itself will give us 49. 2 to the sixth power. Wow, that's a large exponent. So 2 multiplied by itself 6 times. Now, I'm going to go ahead with a little bit of disappearing ink here. 2 times 2 will be 4. 4 times an additional 2 will be 8. 8 times 2 is 16. 16 times 2 is 32. And yes, 32 times that last 2 will be 64. 10 to the 8th power. Goodness gracious. Imagine multiplying, whoops, forgot I still had it on Magic Pen. 10 to the 8th power, multiply 10 times itself repeatedly. 1 and 2 factors. There's the third and the fourth. 5 and 6, 7 and 8. Goodness gracious. Now 1 times 1 times 1 is a whole bunch of ones, and then it's going to be a bunch of zeros. In fact, there should be 8 zeros. 1 and 2, 3, 4, 5, 6, 7, and 8, making for a final answer of 100 million. Pause if you need to, rewind, rewatch if you need to. Otherwise, pause the video if you'd like to try these problems on your own. Come on back when you are ready. 3 to the third power, folks, will be 3 multiplied by itself 3 times. 3 times 3 is 9. 9 times another 3 is 27. 2 to the fourth power, 2 multiplied by itself 4 times. 2 times 2 is 4 times 2 is 8 times 2 is 16. 4 to the second power, 4 times 4, also 16. All right. Now, the zero power, the zero exponent, is a trick for every year. Students always misunderstand this and they will write 0. But let's just kind of build our way backwards. What if you weren't looking at, let's do 2 to the first power. Well, that's 2, Mr. Cowan. 2 to the second power, 2 times 2 is 4. Times another 2 is going to be 8, times another 2 is 16, and so on. Tell you what, instead of going forward, let's go backward. 64 divided by 2, of course, is 32. 32 divided by 2 is 16. Let's keep on going. It's almost like we're just getting rid of an exponent or getting rid of an extra factor every time. So 16 divided by 2 is 8. 8 divided by 2 is 4. 4 divided by 2 is 2. And ladies and gents, what is 2 divided by 2? It is 1. Ladies and gents, 2 to the 0 power is 1. Does that only apply to 2? Well, no. As a matter of fact, it will apply to any number. Take, for instance, 5. 5 to the third power. 5 times 5 is 25 times another 25. 125. 5 to the second power. 5 times 5 is 25. 5 to the first power. Well, that's a 5. Now, go backwards. Divide by 5. Divide by 5. Divide by 5. So perhaps you will not be surprised to hear that 5 to the 0 power, 5 divided by another 5, is in fact 1. Any number to the 0 power will be 1. That is the rule. Any number to the 0 power is 1. Actually, there is an exception to the rules. We're in math class, right? I wonder if you guys could figure out what number to the 0 power is not equal to 1. Think about that. But I really want you to understand that any number to the 0 power, if you follow the patterns going backwards, any number to the 0 power will be 1. All right, now what we're going to do here is we're going to write in exponential form. We're not actually going to evaluate. I'm looking at problem A. Problem A has 4 repeated, so I'm going to put 4 in the base, and I'm seeing 1, 2, 3 of them, and that all is all they're asking for, ladies and gents. Show that you understand power form. So part B, I'm seeing 9 multiplied by itself, 1, 2, 3, 4, 5, 6, and 7 times. For a final simplified way of writing this as 9 to the 7th power. Now part C also has a 7, but in this case 7 is the base. 1, 2, 3, 4, 5, 6, 7, 8, and 9 times. So look how those last two are similar. They both have 7s and 9s. Look how they're different. One of them has a base of 9 because 9 is multiplied repeatedly. One of them has a base of 7 because 7 is multiplied repeatedly. Now, how do we crank it up a notch? Well, let's get into some algebra, shall we? It's not always just going to be numeric quantities. So for part D, for example D, I'm seeing n multiplied repeatedly. So I'm going to write n, and I'm seeing it multiplied 4 repeated times, so the exponent should be 4. We're going to write n to the 4th power. For part E, I see both A's and B's multiplied repeatedly. Now in this case, A is multiplied by itself 3 times, and B is multiplied by itself 2 times. Now you cannot put those together because one's a missing value A and one's a missing value B. So you can't sit there and write A to the fifth. No, we're not multiplying. Okay, B to the fifth. No, we're not multiplying. We can only simplify it and rewrite it as A to the 3rd power, B to the 2nd power. All right, Mr. Callan, I get that. I see this n times n times n repeatedly, but how about what if the numbers are different? Well, as you can imagine, simplifying something, why write 3 times 2 when you could simply write 6? And that is what we'll write. 6 times, you may write the dot, you may not, 6 times some number n raised up to the 4th power. Let's do something similar with part G. I'm seeing a 4 and a 3. 4 times 3 would simplify to 12. Now C times another C and D times another D. Now I'm not going to tell you that it's wrong if you were to put D squared C squared, but I'm getting you ready for algebra class. We, if at all possible, will write the variables alphabetically. And of course, always put that coefficient in front. So final answer in the best way possible to rewrite this would be 12 times C squared times D squared. Folks, that's all I have. You'll notice that for problems 2 through 36 evens, you write the direction and the problem and the answer. There's no work, but please make sure to write the direction and the problem along with the answer. You'll also notice that we have a worksheet as well. This is a little snapshot preview of the worksheet. So take care of that worksheet no matter what the day, no matter what the assignment number. Take care of the worksheet, please. Go on to the textbook assignment. Take care, do well, and let's grow. See you, folks.